Gym class, and today we will be learning about the concept or idea of torque. Now, torque in a general statement is the measure of how much force acting upon an object causes that object to rotate. Now you might be asking yourself, what does this mean? And to understand this concept, let's look at this drawing I've created up here of a wrench on a screw or a bolt. And what torque is a force that is acting upon this object. Now this force is very specific in that it is acting upon this pivot point, and this point that is the pivot is the fixed point on this object that doesn't move, it stays stationary. And this force that is acting perpendicular to this distance away from the pivot point, this distance vector, that causes the object to rotate is what we call the idea of torque. Now torque mathematically is in the Latin tau equals force times distance. The force times the distance equals the measure of how the object will rotate. And this force is, as we said, is perpendicular to this distance vector, which is called the moment arm. And the moment arm is the distance from the pivot point to that particular force. And now you might be asking yourself, well, this force times distance equation looks awfully familiar to work. And this is a very important statement that torque and work are two different things. And let's look at why. And one of the reasons why is that in work, let's say that you have a mass and a force is acting upon that mass across, and and there's a distance. Now with work, the force and the distance act in the same direction or parallel, and the object is being translated across the same direction. But in torque, the force is acting perpendicular to the distance vector, or what we call the moment arm. And that is a big fundamental difference between torque and work. And another crucial thing we should know about torque is that torque, the force is in newtons and the distance is meters. Now that we know the basic general idea of torque, let's look at a real life scenario or application of what we learned. Now that we understand the basic idea or concept of torque, let's look at this door. And in this example, the hinges here act as our pivot point that we talked about earlier. And the moment arm in our situation would be the distance away from this hinge. And if we look at this, if we only apply a little amount of force, a little distance away from the hinge, it's hard to move and barely moves. But if we increase the distance away from the pivot point or the hinge in this example, and move the force, the torque is greater, or the leverage is greater. And as you can see, just a little amount of force causes the leverage or torque to increase. And this would make sense, as we talked about earlier, that as the distance increases, the torque will increase, or if the force increases, the torque will increase as well. And we see that the force I'm using is perpendicular. If it wasn't perpendicular, let's say if I attacked it from the side or at an angle, it doesn't give me that same result I would get if it was perpendicular. And there you have it.